Hi guys, welcome to another episode of MrLopezClasses.com. This is the second episode of the chapter 2 of our gasoline engines course. In this episode we are going to continue with the fuel system. We are going to talk about a couple of outboard two-stroke engines. First of all, we are going to talk about a Mercury Optimax. It's a two-stroke engine, direct fuel injection, common rail, and we are going to analyze what happened in that engine. That engine used an air compressor. Yes, in the common rail, the fuel and the air are at high pressure, and there are a couple of fittings to check the pressure of the air, the pressure of the fuel, and we are going to verify how is the procedure to use the gauge in order to verify those pressures in that particular engine. This is a special engine, and I want that you enjoy this analysis. We are going to work with Professor Rodriguez together in those engines. In the second engine, we are going to analyze an Evinrude E-Tech two-stroke direct fuel injections. This is a special engine because the injectors are individual per each cylinder, and each injector is, the reference is 55 volts DC. It's a lot of voltage. 55 volt DC, and the configuration of the spark plug and the injector is a special configuration in order to improve the performance of those engines. We are going to check both engines, and we are going to review different parameters in each particular situation. Right now we are going to start with the Mercury Optimax, and we are going to analyze the fuel injection system from the beginning, from the low pressure side, the high pressure side, the common rail, and Professor Rodriguez work on the fuel system, explaining how to check the system and the troubleshooting. Professor Rodriguez, what is the first step?
First step, okay, if you come on this side, the first step is you have the lift pump. The lift pump is what draws the fuel from the gas tank to the filter. And from the filter it goes into the high pressure pump, which actually has a float that it gets to a certain point, and then the high pressure feeds it to the fuel rails.
The common rail.
Okay? And the fuel rail on this system, you have air injector and you have a fuel injector. This is a direct injection engine. Okay? So what happens is one side is gonna have air, and the other one side is gonna have fuel. And there's two fittings.
What is the oil in this engine?
There's no oil. This has a little oil reservoir in the boat that feeds with crank pressure. Put pressure into the oil tank to feed it to the little oil tank, which the oil tank feeds gravity-wise to the oil injection pump.
Danny, in other words, this is a two-stroke outboard engine with the oil lubrication separated.
Correct.
Oh, nice, nice. It's a wonderful design.
The oil and gas really never mix, not like your traditional two-stroke.
Correct.
Which is the carburetor, which gets 50% oil, 50% fuel, and the rest gets expelled out. So in this system here, once the system is pressurized, you have two fittings. You have one that's fuel and you have one that's air. We're going to put a gauge on it to show you how it works. Now, how the air system works is basically in this particular model has another motor here, which is the air pump, which has a piston, it has reed valves, just like another engine, but it just pumps air. And that is what pressurizes your injection system.
In other words, we are going to check separated the pressure for the air and the pressure for the fuel.
Right. And normally 90 pounds of pressure is for air and 80 pounds of pressure is for fuel.
For fuel. All right.
Okay?
That's good.
And we're going to demonstrate how that works. And these are the fittings that you have. Okay.
Okay. This fitting is for.
This is for the air. And this was
for the fuel. And we have a separate gauge.
Yes, we have a gauge that has two gauges that reads both at the same time.
All right. Correct. That's perfect.
Now we'll go to the other engine.
Okay. We are going to refresh the low pressure pump. What is the low pressure pump?
Low pressure pump is electric. Now they do have mechanical. This particular model has an electric lift pump.
But there are other one mechanical.
There's other one that's mechanical, and the mechanical works use the crank pressure.
Correct.
The pressure in the vacuum on the crankcase.
Correct.
Draw the fuel from the fuel tank.
It's with differential pressure, not with mechanical length.
Correct. So it uses the vacuum and pressure of the crankcase.
Correct. This is a low pressure pump.
This is the low pressure pump. In this particular case, it's an electric pump.
Correct. And the high pressure pump?
The high pressure pump is called EST.
Correct.
Which the lift pump fills the canister up, and then the high pressure pump pressurizes it to be about 42 psi.
42 psi. I have a question, Danny. Exactly similar to this one. Is difficult replace that fuel filter because the pressure on the can is high pressure?
No, it's low pressure.
It's low pressure.
It's low pressure.
It's simple.
This low pressure is between 4 to 7 psi.
And how much is the pressure?
And this is going to be between 35 to 42 psi.
Some recommendation when you replace that filter or not? It's not
You should replace that filter once a year.
once a year. And how to bleed the system? Is necessary to bleed the
No,
system?
this system you don't need to bleed it. What I would tell you to do is to fill up the canister with fresh fuel, and then you put it in so you don't have to prime the system up. It'll be already primed.
Correct, perfect. All right, nice.
Okay?
Okay.
Gauge. There's your gauge here. And then you're going to hook one up to the air side, one to the fuel side.
For the fuel. What gauge is for air?
This one here
That's for
is for fuel, and this one is for air.
For air. Air and fuel.
So we're going to turn it over so you can see it.
All right. Danny, what happens if only the air pressurized and the fuel goes down?
Okay, so what happens is if the fuel pressure is not up to par, the injector is not going to be able to fire the fuel in the cylinder. And if the air pressure is lower than the fuel, then fuel will be dumped into the air is what keeps it equalized.
Oh, that's
why you need 90 pounds of pressure and 80 pounds of fuel pressure.
This is the normal.
On this system, correct.
Okay, what is the symptom when both of them are below?
Well, first of all, it won't run.
Oh yeah.
It won't run.
All right.
Especially in some cases on these, they have what they call a tracker valve, which you see here is the tracker valve. This is what separates the fuel and the air. It's the tracker valve.
The air and the fuel is separated.
Separated from there.
Nice.
When that diaphragm goes bad, what happens is now you'll have fuel into the air side.
Oh, okay.
And then you have to replace the fuel.
Is possible disassembly the rail and replace the valve?
According to the EPA, no, you cannot. They're not repairable.
Okay.
You have to replace.
You need to replace. All right. Okay. This common rail, because this is a V engine, this common rail is individual of this, or they work together?
Well, they're tied in together with a fuel line.
Okay.
But this side controls this side, and the other side controls the other side.
Okay. And both of them control it from the computer.
From the computer, right? The computer tells it when to fire because it has a crank position sensor that dictates when it needs to fire.
Oh, okay. Thank you. All right. Thank you. Another recommendation, especially for this system, or this is basically the.
This is a basic direct injection system. Okay. This is the Mercury version. You will go to another version, which is the E-Tech version with the Johnson Everett, and then they have one that's called the HPDI, which is the Yamaha, which has a similar pump, but that pump is actually an oil injection pump, and it doesn't have an air pump. Only Optimax Mercury motors have the air compressor pump.
Okay. In order to do a summary of the system, you need the set of the gauge.
Yeah.
And what other tool you need to check the pressure on the system?
Well, that's really the only thing you need to check the pressure. Now, you will need to check is on this side, since we have the fuel pump available, you would put a fitting in line to make sure that this is between 4 to 7 psi's. Because if you don't get fuel from the lift pump side, what happens is you don't have enough fuel pressure, not enough fuel for the high pressure side.
Correct. Is possible remove the output hose of the high pressure pump to verify if the pump is pumping?
Yes.
Okay.
You could actually do that from right here.
It's not dangerous?
No. Well, it's got 42 psi's, so you have to be careful.
Oh yeah. Okay. All right. And any other recommendation in relation with the high pressure pump?
Well, the high pressure pump obviously it has a float. So what happens is you have a float that it allows only a certain amount of fuel. Because if not, it'll bleed out, and there's a dump off. It's like a vent. Which actually this line's been cut, but it'll actually go right back into the intake. So if there's an overflow, and then what happens is if there's an overflow, then the engine will run rich because it's getting too much fuel.
Danny, exactly the same like in other engines. If I have a problem with the low pressure pump, can I install any other low pressure pump in series?
No. You want to use only the manufacturers.
All right. Okay. Only according with the manufacturer specifications. All right. The spark plugs for this system have a special recommendation?
Yeah. Well, these spark plugs here it's a iridium plug. It's a high-end plug. They're pretty expensive. They're designed. If you see on the inside here, which you have the spark plugs off, they're angled in a certain way, so that way when it spits the fuel on it,
Correct.
it burn properly.
Correct. Okay. Danny, in regarding the Optimax, we was speaking to the student the procedure for both common rails, one common rail per each bank, and about this specific valve. What is the function of that valve?
That valve is a tracker valve, and what that does is separate. Remember we said before that you have air, the air compressor puts air 90 pounds, and then you have the fuel pump that puts 80 pounds. And so the tracker valve is what separates the both, and it kind of regulates the pressure. If the tracker valve goes bad, then you'll actually have fuel that'll enter the air side and it will damage the air pump.
Oh, okay. And we have the port to check the air and the fuel.
And the fuel, correct.
Correct. Okay.
Just like we saw in the other video.
Correct. And what about this?
That's your regulator.
The pressure regulator.
Pressure regulator.
Oh, that's incredible. In some engines, Danny, that pressure regulator is adjustable. This is not adjustable.
No, this is not adjustable.
Okay, because if you remember, guys, in diesel, the pressure regulator is adjustable. You can increase or decrease the fuel pressure in order to get better fuel pressure into the injection pump. Here, it's not adjustable.
No, it's not adjustable.
Okay, all right. But what is the symptom when the pressure regulator is damaged, Danny?
Well, a couple things could happen. You might not have enough pressure, or you have too much pressure.
Oh, yeah, it's possible too much pressure?
Absolutely.
Oh, yeah. In that case, the solution is
to replace. Now, there is a screen in there that you can actually take and clean. If you see some debris in the screen,
okay,
then you can clean it out and retest the system.
Okay, perfect. All right, this is Optimax.
Optimax.
Two-stroke.
Two-stroke Mercury Optimax.
Mercury Optimax. Danny, one more question. What about the injectors? Is a different injector?
Well, the injector, how this system works is the computer controls the injector according to the crank position sensor. Each injector uses a 5-volt reference. So when the engine needs to get more fuel in the cylinder, it gives it 5 volts right from the computer. It controls the negative side of the injector.
The negative side. All right, correct. Can I check the injectors exactly the same like in diesel engine with the engine running? Can I check if the voltage enter?
Yes, you can.
All right. With you prepare your multimeter with a couple of...
Correct.
Perfect. Okay.
And you can also do a drop-down test if you wanted to isolate the cylinder. And if you, let's say you have good compression and good spark, and you think it's a bad injector, you can unplug each one and see if the cylinder changes or not.
Okay. All right. Thank you. And now we are going to continue with the Evinrude e-Tech. We are going to start checking the intake manifold once again, the throttle body, and after that we are going to verify the path of the fuel, the low pressure pump, the high pressure pump, and we are going to verify each of those parameters. Danny, in this type of a two-stroke engine, this is the e-Tech. The majority of the people say that's the oil pan. This is the oil pan?
No, this is actually the throttle body.
Oh,
this
really?
is the throttle body like you've seen on the other video with Glenn.
Correct.
This is the same system. It's just a little bit different because
that's the intake manifold.
It's the intake manifold.
That's the intake manifold. Yeah, it looks like an oil pan, no?
Right. It does look like an oil pan if someone doesn't know. They
would.
But you can see that this is actually the throttle body here.
Correct. And the throttle position sensor.
Right.
Yeah, because this is the crankcase. This is the bracket for the reed valves.
Correct. This is the bracket for the reed valves back here.
Yeah, correct. All right. That's the intake manifold, and that's the throttle.
Correct.
All right. Now we have another engine, two-stroke, high technology. This is an Evinrude e-Tech with a special specification for the injection system. We are going to analyze this system. This is a special system. Professor Rodriguez explained step by step. We are going to start, Professor Rodriguez, in the low pressure side. The low pressure side is a composition of mechanical and electrical.
Yeah, this one's actually mechanical. So this part here is your mechanical fuel pump. This one uses the vacuum and the pressure of the crankcase. There's two inlets, okay? And now there's a diaphragm that moves in and out like this to draw the fuel from the fuel tank to the filter, and from the filter it feeds all the way to the high pressure.
The low pressure, and after that the high pressure.
And then it pressurizes. There's a pressure regulator built inside this.
Because we have two low pressure pumps. One low pressure pump, pneumatic, because it's working with differential of pressures. And after that, pass through the filter and enter in the other electrical low pressure pump. And after the electrical low pressure pump, enter in the high pressure pump.
Correct. And also just so you know that this particular model has a sensor that detects water.
Oh, nice.
Two little electrodes.
The water separator.
It's in the water separator. It actually has two electrodes that'll tell the computer that there's water in the system.
Oh, okay. And it's possible to replace the fuel filter for a filter with a transparent crystal in order to verify.
Only the manufacturer specs.
Oh, all right. Okay. All right. Okay. Now we are going to continue. The fuel enter in the secondary pump, and the secondary pump enter in the high pressure pump. What about the high pressure pump?
So the high pressure pump, what it does is it pressurizes. This one's between 28 to 32 psi.
32 psi.
And so how this works is it's got two fittings. It has a high pressure fitting, which you can check your high pressure, and you have the low pressure that you can check the low pressure. Correct. Same thing, 4 to 7 psi's on the low pressure side, on the high side between 28 to 32 psi.
Oh, okay.
And so how this way, and the pressure regulator is built inside, and this is actually a water cooled system compared to the other one. So if you look here, you actually have hoses that from the raw water pump. There's a coil that goes in here that cools the fuel down.
Exactly. This is a pump with a fuel cooler integrated. Danny, this is the element that the majority of the cooler pumps have internally?
Correct. Most of this model has that. And when the water passes through those coils, cools the fuel down to keep the temperature.
Oh, the water is passing inside of the pipes.
Inside the pipes.
Okay. And the coil is at low temperature, and
and what keeps that cool is the pressure of the water pump.
Correct.
Runs through the engine. Actually keeps that cool.
Yeah, the majority of the fuel injected engines have this system. No?
Yes.
All right. Okay. That's the high pressure pump. Okay. What is the next?
So once it pressurizes, it goes through a fuel rail, which is a hose, which is different than the Optimax, which actually feed into each individual injectors. These are the injectors right here.
Injectors are similar to the previous one, or
no? They're different. The previous one was said it worked off a 5 volts reference.
Yeah.
This is actually a 55 volt circuit.
55 DC.
50 volt. Yeah, they call it the SAC circuit, which is the 55 volt circuit.
And how those injectors work different like the other?
Okay, so how this works is actually has an electromagnetic injector. It actually controls the polarity of the injector. So there's a mapping system on the software that when it takes the air temperature, the temperature of the engine, the RPMs, and it'll calculate and tells you exactly how much fuel you need. That's why these are more fuel efficient than any of the other engines out there.
Of course, it's controlled.
It's controlled, correct. It's actually a polarity injector. They can control the polarity of it.
Oh yeah, and the troubleshoot is difficult?
It's somewhat, this one here, you can do the same system. If you have compression spark, you can disconnect it and you can find the problem that way. Or you hook up a computer and you can do the diagnostics. Now the only thing the computer won't read is if it's a mechanical failure.
Yeah.
But if it's electrical failure, it'll show up on the computer.
Guys, don't forget, 55 volts, no? It's a lot
55 volts.
Yeah.
And the coils also work off the 55 volts as well.
Danny, I have a question. How can you get 55 volts if the boat is 12 or 24?
Okay, so how this works is you have the stator, okay? There's a two-part of the stator. So basically it's like having two stators in one. And what happens is the engine actually has a capacitor, which I'll show you. But how this works is if you come here,
that's the flywheel.
That's the flywheel. As this rotates, it generates AC current.
AC power. AC power, correct.
And then from the AC power, it's going to the computer, which converts it into DC by using a regulator.
The rectifier is in the computer.
Correct. And then once it does that, there's a capacitor.
When the current is rectified, enter in the capacitor.
And it's stored.
And it's stored. When the capacitor is full charged, the capacitor
discharges it and sends it to the system.
Correct.
And that's how you maintain your 55
And you
volts.
check this capacitor exactly the same like in other videos we checked?
Absolutely.
All right, the same procedure, we discharge the capacitor.
Absolutely. Same
all right,
procedure.
nice. What is the capacity? That capacitor is 50,000 microfarads. 50,000 microfarads are 50 volts.
Correct.
Correct. Okay, the procedure is exactly the same like we use in other episodes to check the capacitor. Normally when the capacitor is damaged, it
swells up.
Yeah.
And these, what we see a lot of is what happens is because when it's actually installed in the motor, it's upside down. Sometimes the seals go bad and it'll leak out.
It's leaking.
And you'll see when you pull the boot out, you'll see actually the oil in there.
And this is poison.
Yeah, it's poisonous.
All right. Okay. Perfect. We have 55 volts on the injectors. And yes, when we remove the plugs, we can verify with the multimeter the 55 intermittent.
Correct.
No? Depending on the signal
Yep.
from the computer.
Yeah.
All right, perfect.
There's also like on the previous engine that we looked at, you can take an injector and swap it to whichever cylinder.
Yeah, yeah.
This one you can't. You actually have to program each, and there's a programming code right here
The number of
that
it.
tells you, so the computer knows who it's talking to. That's how it controls the polarity of the injector. There's no default. There's actually a software for each individual one, so the computer knows who it's talking to.
Danny, according with this, the ground in this type of engine is critical.
Oh, it is absolutely most important.
Yeah, the most important.
Corrosion, it will absolutely cause electrical issues.
A lot of complaints related with the low pressure, intermittent pressure is because background.
Backgrounds, correct.
That's okay. It's critical.
And then as far as on the spark plugs in this, is using a champion plug. It's really a bunch of traditional
How the
plugs.
spark plugs work together with
Yeah, so how the spark plug works, so the coil system, it gets its power once it gets it from the computer and it shoots. But this one, in this case they call it the indexing. So if you look here in the line, you make a line for the open electrode. Okay? So when you install this, you have to install either, you can be 90 degrees or 90 degrees the other way, 180 degrees.
The opening in front.
Yes. If you do it this way, what happens is the spray pattern is disrupted, and what happens is it will work, but it'll foul out the plug.
Oh, incredible. And what is the symptom? Misfiring.
Misfiring.
Oh, nice. It's only because the position of the spark plug is not appropriated in front of the injector. Normally, it's like this, no, in the combustion chamber.
Correct. Yeah, you want it facing
like this. That's perfect.
the open electrode.
Oh, incredible. Incredible. And in the manual is the recommendation?
Yes.
All right.
They tell you how to index it.
Perfect. Okay. In other words, this is the injector, the 55 volts. That's the injector. This is a special injector for ultra high pressure, and this is the spark plug. Any other recommendation for the fuel system? What is the procedure? Okay, you check the high pressure over there, the low pressure with the same gauge.
Same. Well, yeah, same. Not the same exact gauge, but another gauge, but it'll be very similar.
Okay.
But also, this one has a return line.
Oh, the return line for
So
the
it has a
accessory.
return time. So the return line is actually on this side. So with a fuel that it doesn't use, it brings it back in.
Correct.
So if you have dirty fuel, there's a cone filter that goes in that catches all
Like
the
a
debris.
check valve.
Like a check valve. It catches
Oh,
all.
right.
So every once in a while, you may have too much of a high pressure.
Uh-huh.
And if you have too much of a high pressure, you have to check
And the return line goes directly into the fuel tank.
directly into the fuel pump.
Oh, into the fuel
It
pump and
recycles.
recirculate.
And
Okay.
recirculates.
All right, that's wonderful.
And then it has also the same thing as the vent, like the other one.
Uh-huh.
If there's, for some reason, there's actually a little float. If it's not working, it'll actually dump the fuel right back into the intake. So
Okay.
it consumes it.
Okay, guys, in this particular engine, in the E-Tech Evinrude, you have injectors with 55 volts DC. For that reason, I recommend, not only because this engine, in general, I recommend try to keep a source of DC power. This is basically an rectifier that converts AC power into DC power. And you can calibrate the output 13, 9 volts, 12 volts, 22, 24, 36, 34, 30, yeah? You can calibrate the output according with this dial. With this equipment, you can get 55 volts, and when you have 55 volts, you can verify if the solenoid internally in the injector is working, and you can hear the click. This is an indication that the solenoid is, in this particular case, in good condition. Remember, the solenoid, this is the output, the jet, but this is the input of fuel, and this is the return. This is the input and this is the return, and this is the discharge internally in the combustion chamber. Alright, I recommend the source of power DC is very important, because with this you can check any type of injector. For example, the signal for this injector is 5 volts DC. I am going to calibrate to 5 volts DC. Okay, 5.1, and I am going to check those injectors. if I introduce fuel at high pressure here with a priming pump, I can verify the pattern of the fuel coming out through the injector. Don't forget, very important, the source of a DC power. Other important element that I recommend verify is, this is the high pressure pump for the previous engine. This is the high pressure pump where the fuel and the oil is mixed. Yes, the fuel enter here, fuel coming in, fuel return, and oil coming in, oil return. If you disassemble the pump, you found that the float, this is exactly the same float like the carburetor. You have the needle and you have the base over there and you have the float. Yes, probably when the fuel enter over there, if the fuel is contaminated, the needle is clogged, and for that reason the pump or the system work improperly. You can replace the needle, you can replace the base, and you can replace the float. And the pump, you can replace the pump, the electrical pump. This is a special 12 volts pump. You can verify with the source of power, and you can replace the pump. And also you can verify the pressure of the system. You can verify the pressure of the system here in this outlet. The procedure is similar. The only that I recommend is try to get a kit to check fuel systems, and you introduce the gauge over there and you verify the pressure of the pump. It's simple. The only that you need is tools. You need too much patience, you need be organized, you need be clean, and you need be analytic. Once again, if you have the wiring diagram of those elements, and if you have the service manual, you can replace, use the pump, use the flow switch, use the needle, and you can repair an expensive pump, because this pump is expensive. This is not only for this engine, this is exactly for the same of the outboards or inboards. Once again, the procedure to check the fuel system is simple. You need a start in the fuel tank. Verify that the fuel in the fuel tank is clean, no water. Verify that the flow switch in the fuel tank is working properly. You need to verify that the transfer pump or lifting pump or priming pump is working, low pressure pump. You need to verify that the second pump, the high pressure pump, is working properly. You check the pressure and you remove the outlet and you verify that the pump is pumping, and you verify that the fuel enter in the common rail, and also you disconnect the return and verify that the return is coming out to the tank. Okay, if you have power fuel coming in and fuel coming out, you can remove the rail and you can produce excitation in each individual injectors and verify the pattern of the injector if you have pressure at the input. And you verify the pattern of all the injectors. It's easy. You remove the rails, you introduce the fuel, you connect this one into the fuel tank, you pressurize the system, and you produce individual excitation on the injectors, and you verify the pattern of the injectors. It's simple. If one injector is not opening or is clogged, you remove the injector, you replace the injector for the new one, and you continue with the system. That's the procedure. If you have fuel, the next step is verify if you have current, if you have a spark. And this is our next chapter.